We're going to talk about solving absolute value inequalities. When you have an inequality sign and an absolute value, you can write it as a compound inequality. Now, here's kind of a little trick. Make sure that you isolate the absolute value first. Then, as long as the absolute value is on the left-hand side, okay, and then you have your inequality sign right here. If your inequality sign is greater than or equal to, then this is going to be this is just a little trick, great or, it's going to be an or compound inequality. If once you've isolated the absolute value, the sign to the right of it is a less than or equal to, then it is going to be, let's see, that was less than, it's going to be an and compound inequality. Okay, let's go back and review really quickly first how you solve an absolute value equation. The first thing you have to do is isolate the absolute value. So I'm going to start by adding 5 to both sides here. Okay, remember you do the order of operations backwards when you're solving. That gives me a 2x minus 4 is equal to 9. The absolute value is still not isolated, so I'm going to need to divide both sides by 3. Here the 3's cancel out. I'm left with the absolute value of 2x minus 4 is equal to 3. At that point, once the absolute value is isolated, we set up two inequalities. Okay? Not inequalities, two equations. One equation that will equal 3, and the other equation that will equal the opposite of that, which is negative 3. Now, this is what goes out there. So 2x minus 4 is equal to 3. 2x minus 4 is equal to negative 3. Solve these two individual equations. Here, add 4 to both sides. I get 2x is equal to 7. X is equal to 7 halves or 3 1/2. Okay, for this one, add 4 to both sides. I get 2x is equal to 1. Divide both sides by 2. X is equal to 1/2. Okay, so now let's do this with the inequalities, all right? There's just two differences. The first one is you have to decide if it's going to be an and or an or compound inequality. And the second thing is when you write the opposite option, like on the other one we did positive 3 and negative 3, when you write the negative 3 option, you have to use the opposite inequality sign also. So in other words, you have to flip the inequality. All right, so let's go ahead and do this. Ready? Step number 1, isolate the absolute value. I'm going to do that by adding 3 to both sides. That's going to give me the absolute value of x is less than 2. So this is a less than, then this is going to be an and situation. So put one of them on one side. X is less than 2. That's exactly what's sitting right here. And now the other one's going to be x is, now this is where I'm going to take the opposite of this and make it a negative 2. And because I do that, I flip the inequality sign over. Okay? Remember when it's and, you can actually take them and combine them together. You just take the one with the smaller number and flip it over. So negative 2 is less than x. Then take this one and write it. X is less than 2. When you go to graph this, this is going to be an open circle at negative 2, an open circle at positive 2, and all of the x values in between. Remember, with an and compound inequality, you're only graphing where they overlap each other. Okay, in this case, the absolute value is already isolated. This is a less than or equal to. So again, this is going to be an and situation. Okay, so in this case, it's going to be x minus 1 is less than or equal to 2, and x minus 1 is, flip this over, greater than or equal to negative 2. Let's go ahead and solve these. Add 1 to both sides here. You get x is less than or equal to 3. Add 1 to both sides here. Plus 1 plus 1. X is greater than or equal to negative 2. It's going to be a negative 2. It's going to be a closed circle. Okay. going to go this way. This one's going to start at positive 3, and it's going to go this way, so it's that area in between there. Again, if you take this and flip this one over, that'll be negative 2 is less than or equal to x. You'll notice it's pointing towards the negative 2 here. It continues to point towards it there. Put this one right on top of that, and then it's very easy to see that all your x values are between negative 2 and 3. Okay? Let's go this one. This time the inequality sign is different. Subtract 14 from both sides. I get the absolute value of x is greater than or equal to 5. Set up, so this is great or. So I'm going to get x is greater than or equal to 5, or x is, again, flip the inequality sign over when you make the negative. Okay, since it's an or situation, you just put both of them on the same graph. So x is greater than or equal to 5 is a closed dot at 5 with an arrow going to the right. Or x is less than or equal to negative 5 is a closed dot at negative 5 and an arrow going to the left. Okay, let's try this one. Let's subtract 3 from both sides here. So minus 3 minus 3. You get the absolute value of x plus 2 is greater than 2. Again, this is an or situation. So we're going to get x plus 2 is greater than 2, or x plus 2 is less than negative 2. Now, let's go ahead and solve each one of those. Subtract 2 from both sides. You get x is greater than 0, or subtract 2 from both sides here. X is less than negative 4. Graph them on the same number line. This one's going to be a open dot at 0 with an arrow going to the right. This one's going to be an open dot at negative 4 with an arrow going to the left. Okay? Here's the hard part. Here's where we're going to take a word problem and we're going to turn it into an absolute value. A pediatrician recommends that a baby's water be 95 degrees, but it is acceptable for the temperature to be up to 3 degrees over or under that. Write and solve an absolute value inequality to find the range of acceptable temperatures. So we're going to let T be the temperature. Now, to find the difference between the actual temperature and what they suggested is, we'll subtract that to find the difference. And it can be up to 3 degrees. So that means it has to be less than or equal to 3 degrees. Now, what makes this an absolute value is I have to be able to show that it can either be positive 3, like 3 degrees over, or 3 degrees under, but I don't want that to affect my outcome, so I put that inside the absolute value. Okay? And then you just solve it. So I've got T minus 95 is less than or equal to 3, and T minus 95 is greater than or equal to negative 3. Solve these. T is less than or equal to 98. T is greater than or equal to 92. So that basically means the bath water has to be somewhere between 92 and 98 degrees. Okay? Now, sometimes when you're solving these, you're going to end up with a statement that like is always true. That means any variable is going to work, or that's always false. That's never going to work. And it's not as clear as it was before where the variable would disappear, but you have to be thinking logically. So let's look at these and see. I'm going to start here by adding 5 to both sides of this inequality, getting ready to solve it. And I get the absolute value of x plus 4 is greater than negative 3. Now think for a minute. Absolute value means that the answer is going to be what? Positive. Always, always, always positive. Every single positive number is greater than negative 3. So this would be any real number we can use in there. Okay, let's try this next one. Start out by subtracting 9 from both sides. That gives you the absolute value of x minus 2 is less than negative 2. Again, think. The absolute value of something is always positive. Are there any positive numbers that are less than negative 2? No, because everything less than negative 2 is negative, so this is no solution. And that's it.